This example illustrates how by adding either a shunt resistor in series or parallel, one can completely change the properties of the original circuit. So in this problem you have a meter. The meter is designed to measure 0 to 50 microamperes, and it has an internal resistance of 5 kilo ohms. So the insides of the meter looks just like this. It has a 5 kilo ohm resistor, and when you pass a current 0 to 50 microamps, a voltage will appear across this resistor, which is measured with a voltmeter, let us say with a needle, that indicates the current. And of course the voltmeter doesn't measure current, it measures the voltage. So what is the voltage that you read? The voltage across the resistor that you read will be a maximum voltage of 0.25 volts corresponding to the maximum current 50 microamps. So 50 microamps times 5 kilo ohms, the IR value would be just 0.25 volts. So it's a voltmeter that reads a maximum of 0.25 volts, which is actually a current meter. So the question is, you want to convert this 0 to 50 amp microamp current meter to a 0 to 1 amp current meter. And how can we do that? Well, we just need a larger current going through the circuit. Means that you can't drop that large current through the large resistor here, so you have to add a resistance in parallel, which we call as the shunt resistance, and the total voltage in that case should still be 0.25 volts, because that's what our meter is designed to measure. It's designed to measure voltage. So let's see what that shunt resistor should do. So there's my 0.25 volts, which is the final result that I still want. So I would like to add a shunt resistor in parallel like this, so that with the 0 to 1 amp current going through both the resistors, the sum of the current going through both the resistors will give me a total voltage drop of a quarter volt. So the value of this resistor clearly uh, has to be very small, because this is a large current and we want to keep our maximum voltage at 0.25. What is the value of that resistor? That resistor will be, since these two are in parallel, 0.25 parallel to 5 kilo ohms will of course be very closely equal to 0.25 ohms, and 1 amp through 0.25 of course will give me a quarter volt. So the answer is you need a shunt resistor in parallel. Now let's look at a different situation. So we have the same voltmeter, or ammeter rather, which gives us a voltage of 0.25 volts when we have a maximum current of 50 microamps. So the question is, what series resistance is needed to convert it to a 0 to 10 voltmeter? So we want this voltage when that current goes through to be 10 volts maximum for 50 microamps. So obviously you need to drop a larger resistor, which takes the full 50 microamp current to give you the larger 10 volt reading. So how does one do that? You add a resistors in series, so that the total resistance, the sum of these two resistors taken together multiplied by the 50 microamps will give me the 10 volt. So what is the value of that resistor? That's 200 kilo ohms, and since we already have 5 kilo ohms, the additional series resistor one needs to add is 195 kilo ohms. So you can easily verify that 195 plus 5 is 200 times 200 kilo ohms, which is 2 times 10 to the 5 times 50 microamps is 5 times 10 to the minus 6, will give you 10 volts.